Hi everyone. In this video I'm going to cover effect coding in multiple regression and specifically we're going to be focusing on effect coding using multiple regression in IBM SPSS. So in the video what I'm going to do is to show you how to perform effect coding, how to run the multiple regression, and then how to make sense out of the results. A major part of the presentation will be involving comparisons between multiple regression using effect-coded variables and analysis of variance and ANCOVAs that are carried out using the general linear models option. Let me also note before we get started that a lot of the information that I will be covering is presented in a PowerPoint that will be made available underneath the video description. Also, the data sets that are used for the presentation and in the PowerPoint will be made available as links underneath the video description as well. So be sure to check them out. So let me begin by just kind of talking about the nature of our data. Basically, we have essentially fabricated student data where we have a measure of educational level, gender identification, subject matter interest, mastery goals, anxiety, and achievement. Educational level is essentially a self-reported education level variable. It's coded 1 for very low, 2 for somewhat low, 3 for somewhat high, and 4 for very high. Gender identification is coded 0 for identified as male, 1 for identified as female, and then subject matter interest, mastery goals, anxiety, and achievement are all treated as continuous variables. So before I actually begin with demonstrating how to perform and interpret effect coding, let's start with a demonstration where we will run a one-way ANOVA with self-reported education level as the independent variable and achievement as the dependent variable. And we'll go ahead and open up our raw data. So this is the data set that you can download, and you'll notice that I've already have included the effect-coded variables for education level. There's an effect-coded variable for gender identification, and there's a mean-centered variable, and we'll get to all that later on. Mainly we're going to be focusing in on educational level as it's related to achievement. I'm going to start with that ANOVA that I was telling you about. So what we're going to do is we're going to go to Analyze. We'll go down to General Linear Model, go to Univariate, and we will move Educational Level over to the Fixed Factors box, and we will move Achievement to the Dependent Variable box. Under Options, I'm going to go ahead and ask for some of the usual things that I typically request: descriptives, effect size, power, homogeneity tests. And under EM means, this is estimated marginal means, and I'm going to select both overall and educational level and move this over. And this is going to give us the group means that we're going to be working with. So the next step, what I will do is I will click on OK, and we'll just take a look at our output. So you can see in the descriptive statistics that we have our group means that are given. So there's the mean achievement level for very low educational level, somewhat low, somewhat high, and then very high right here. Next, I'm going to scroll down, and you can see with the tests of between subjects effects, we have the independent variable educational level. You can see there's our F-value and there's our P-value right there, and this is indicating that we have significant differences among our groups with respect to our dependent variable academic achievement. Now, you'll see also that as we scroll down, you'll see that we have a grand mean for achievement. And then you can see down here that we have our group means that are reproduced. Now the key thing to note is that although these means right here are the same as those that were reproduced above in the descriptive statistics, this mean right here is actually the grand mean of all these group means. And so this grand mean then that's computed by the average of all the group means is essentially not adjusted for differences in group sizes. And that's why the grand mean that you have right here of 97.849 is not equivalent to the total mean across all of the individuals in the sample of 98. So that's why there's a difference there. And this is going to be an important distinction or an important consideration when we start reparameterizing our model via effect coding with multiple regression, where you would have equivalence between this grand mean right here and the overall mean above in the descriptives table of 98 in this particular case. Where you would have equivalence would be if you have group sizes that had equal ends. But again, right here you can see that our group sizes are all unequal, and that's why there's a difference between the total mean across all individuals and the grand mean of the group means, which you see down here. Okay, so now we're going to transition to actually performing our analysis using effect-coded variables in the context of multiple regression. So what we're going to do is we're going to take our original education level variable with values of 1, 2, 3, and 4 right here, and we're going to recode this variable into a set of 3 effect-coded variables. So essentially the number of effect-coded variables is going to equal the number of groups for our original variable minus 1. So you'll notice that what I've done is I've essentially set up each row as reflecting a given level. So there's level 1, level 2, level 3, and level 4. And the coding system is presented in the EC1, EC2, and EC3 columns. So the first effect-coded variable, and remember the number of effect-coded variables is equal to the number of groups minus 1. So for the first effect-coded variable, you'll notice that I have a -1, I have a 1, I have a 0, and I have a 0. So this is the coding on that first variable. The second effect-coded variable, you can see I have a -1, a 0, a 1, and a 0, and so forth. Now, remember what I said, that basically with the recoding of our original variables, we are still containing information regarding all of the group memberships. So essentially, we are, in this particular case, we are demarcating group 1 from the original variable with codes of -1, -1, and -1 across all 3 of our effect-coded variables. And the group that is coded with -1s across all of our effect-coded variables is referred to as the reference group or reference category. For the second level of our original variable, it is coded 1, 0, and a 0. Okay, so then for the third one, we have a 0, 1, 0, and then for the fourth group, you can see codes of 0, 0, and 1. So basically, with our coding system, we are able to identify all 4 groups with our 3 effect-coded variables. And just keep in mind that with effect coding, again, we're using a system of -1s, 0s, and 1s. If we were using dummy coding, we would just be using a system of 0s and 1s to indicate group membership. Let me also note that in this particular case, although we demarcated group 1 as our reference category, this is not a requirement. We could have chosen any group to be our reference category, in which case that category would be coded with -1s across our 3 effect-coded variables. So going back to our data set, let's create these 3 variables again. So what I'm going to do is I'm actually just going to go ahead and delete this and walk you through the steps. So to do this, we're going to go under Transform and Recode into different variables. So we'll click on this. I'm going to move the education variable over to this box and rename it. So the first effect-coded variable, I'm just going to call it EC1. It's an arbitrary name, and I'll click on Change. We'll click on Old and New Values, and now what I'll do is I will say that if you were in Group 1 for the original education level variable, we're going to recode that as -1 on the first effect-coded variable. So I'm going to click on Add right here. Then for Group 2, we are going to convert that code to basically a code of 1 on our effect-coded variable. So I'm going to click Add there. And then for basically Groups 3, we'll convert it to 0, and then group 4 will also be converted to 0 here. So now when I click on Continue and then on OK, you can see that our first effect-coded variable has been created. Now we'll do the same for the other 2. So in this case, I can actually just highlight this, and I'll just type in EC2 and click on Change and then Old and New Values. And in this particular case, I'm going to reset group 2, I'm going to reset this or set this at 0, and I can just click on change right here, and then we will have group 3 be group 1 on our second effect coded variable. So I'll click change right there, and you can see that that's reflected. So next we'll click on continue and then on OK, and so now we have the second effect coded variable. Then the third one, we'll just do the same thing. We'll just say EC3. I'll change this, and old and new values, and in this case I'm going to change 3 to 0. So I'll just reset this and click change, and then group 4 will be our comparison group there, and then I will click on change right there. So now you can see we'll click on continue and then on OK, and so now we have effect coded variables 1, 2, and 3. So now to run the analysis, we can just go to Analyze Regression Linear, and we will move our 3 effect coded variables over to the Independent Variables box and Achievement to the Dependent box. We'll click on OK, and as we're looking at this, you'll notice that we have our regression results that are given down here. So this is the model summary table. You can see there's the R-square value and the F value and P value that's given right here. And this R-square value is going to be equal to essentially the eta squared value from our analysis of variance, and then the F value and the P value will be the same as those that are given in our table above. So I'll just kind of scroll up here, and you can see there's the partial eta squared. This is the corrected model. This is for the independent variable, and when you only have a single independent variable, the eta squared for the corrected model and the eta squared for the factor will be the same. But you can see that basically our F values and our P values are exactly the same as those that are shown down here below. Again, there's the R square value right there and the F value and P value. They're exactly the same. Another thing to note then is our intercept, which is 97.849. If we scroll back up, you'll see from our analysis of variance results, there is the grand mean. It's 97.849, and that is, again, the average of all these group means, essentially ignoring the differences in sample sizes. So that's it right there. When you look at the regression slopes down here, these are basically comparisons between the essentially the target group that has been coded 1 and the grand mean, which was the intercept, or again going back up to our ANOVA results, essentially the average of all the group means. So these are the regression slopes are basically differences. And you could actually think of the effect-coded variables, the slopes, as reflecting contrast or deviation contrast. So let me just kind of show you what I mean by that. If I go back and I rerun the analysis of variance, and if I select, I'm going to actually go kind of fix this because sometimes this newer version of SPSS keeps resetting. But I've requested again the marginal means, and then I'm going to go up here to contrast. And for educational level, I'm going to set it as deviation. And so with deviation contrast, we have to select a reference category. So we have the option of the first group or the last group. I'm going to select the first group, click on change, and so we'll click on continue and then on OK. And so now when we look at the contrast, basically these values that you see right here for the contrast estimates are equal to the slopes for the 3 effect-coded variables in our regression analysis. You can also see the standard error and the p-values that are given, and these are going to be the same values that you see in our regression table. So let me just kind of scroll up. You can see that first contrast is essentially group 2, basically the somewhat low group versus the mean of all 4 groups, which is negative 3.389. So if we scroll up here and look at our regression table, there's the negative 3.389. There's the standard error of 1.796 and the p-value of 0.065. So kind of scrolling back down and just reiterating those points, there's that difference. There's the 1.796 for the standard error, and then the significance level is 0.065. You can see that the t-value is not given in this particular table, but the t-value for that contrast is essentially formed by taking the contrast estimate that you have right here and dividing it by the standard error, which is this value right there. So you would have exactly the same t-value for this test that you see in our regression table. You can see the second regression slope for the second effect-coded variable is 0.69. So this is essentially a comparison of the mean for our somewhat high group and the grand mean of our means. That difference is, there's a 0.69, and you can see there's our standard error and our p-value that's given right here. And if we scroll back down just for our comparison, you can see there's the 0.69 as before, standard error 2.039, and then the p-value of 0.737. So in a nutshell, when we ran our model using effect coding, again, the intercept is essentially the average of all of the group means, again, unadjusted by differences in sample size, if there are any differences, and then the actual regression slopes are differences between a given group and the overall grand mean. And so we've essentially modeled deviation contrasts that we would obtain using the ANOVA approach via the use of effect-coded variables in multiple regression. Now let's try a different one using the gender identification variable. So the gender ID variable is already dummy coded with zeros and ones. So in this case, this is the gender ID variable that was effect coded. So I can just show you really quickly how to create that. Essentially, again, we can go back to transform, recode into different variables. I'm going to reset this, and I'll move our gender ID variable over to this box right here. And we'll just call it, gender ID EC, and click on change. We'll click on old and new values. So the old value, let's say if it's 0, that's for persons identified as male. We will set that as -1. Click on add, and then for persons identified as female on that variable, which are coded 1, we will reset that. We will actually leave this as 1 right here. So you can see there's 0 recoded to -1, 1 basically left as 1, and we'll click on continue and then on OK. And so now we have our effect coded variable right here. So if we run our analysis again through our previous approach, I'm going to take education level out, move gender ID variable. I'll go ahead and select estimated marginal means again to get all of that information. So we'll click on continue. And I'm going to go ahead and select deviation contrast and set the reference category as the first group. That's persons identified as male. We'll click on change right here, continue, and then on OK. So now we have our output again. So you can see that with our regression results, there's gender ID. You can see there's the FA, p-value, and there's the partial eta squared. Again, for the full model, if there was more than a single predictor, then the R-square in the regression would be essentially equal to the partial eta squared that you would see here for the corrected model, and then the F value and the significance level would be the same that's shown in the ANOVA table from the regression results. But again, because we only have a single independent variable, these are going to be exactly the same. So next, looking at our contrast estimates, so this is using the deviation contrast. This is essentially a comparison of persons that were identified as female against the grand mean of the two groups with respect to achievement. So there's the standard error and there's the significance level. And so we are essentially going to expect this to be the regression slope in our multiple regression using the effect-coded gender ID variable, and then we would have the standard error and significance level also reproduced in that regression table. If I scroll back down, you can also see the grand mean, which is 98.123, and that's what we're going to expect to see as our intercept in our regression model. So let's go ahead and do it. We're going to go to Analyze, Regression, Linear, and I'm just going to move these guys out and put my gender ID variable effect coded in. We'll click on OK. And so now as we scroll down, you can see again, there's the R-square value. Again, that's just matching what we saw in the ANOVA table. There's the F value and P value that we saw previously. You can see the intercept, which is 98.123, which is exactly the same as what we see up here with our grand mean, and then our regression slope of 3.073, and then you can see there's our standard error right there and our p-value of 0.005, and again that matches our results from our deviation contrast that we saw previously when we ran this using the analysis of variance. Okay, so next, let's try our analysis a little bit differently. We're going to reintroduce educational level as our independent variable predicting achievement, and we're also going to introduce mastery goals as a covariate. So let's run our analysis using the analysis of covariance, and then let's rerun our analysis to obtain essentially the same grand mean as basically the intercept being equal to the grand mean from our ANCOVA results, and then also our deviation contrast. So let me kind of show you what I mean by that. So we'll go ahead and we'll go back to Analyze, General Linear Model, Univariate. I'm going to take this out again, and I'm going to put educational level back in as a fixed factor, and I'm going to introduce mastery goals as a covariate into the model. Next, I'm going to, again, reset this, where I'm going to move overall to the display means box as well as the fixed factor of education level right there. We'll go ahead and click on contrast again, and I'm going to reset this as deviation contrast. So I'm going to change this, and you can see that we're still using our first group as our reference category. So we'll click on continue and then on OK. And so now you can see in this case, the corrected model, you've got this is essentially the eta squared, which is going to be equal to the r squared. You can even see it down here, and there's the adjusted r squared. These are going to be the same values that you see when we run our model using regression analysis. There's the f value and the p value that's given, and you can also see the individual the tests of the individual effects for mastery goals and education level right here. As we scroll down, you can see in this case we've got, again, our deviation contrast. This is going to be group 2 versus the average of the means for the different groups. There's the contrast estimate, the standard error, and p-value, and the same for group 3 versus the grand mean, standard error, and p-value, and so forth. So we'll also scroll down a little bit further. And now we'll look at our grand mean. So this is basically the average of the group means, but adjusted for the presence of the covariate that has been included in the model. So this number right here is still the average of these means right here, except that now we're adjusting for the covariate in the model. Now to run our analysis using multiple regression and to get the grand mean that you see right here, what we're going to need to do is to first recode our mastery goal variable. Essentially, we're going to mean center that variable and include that in the regression model along with our effect coded variable. So you'll see right here that this is it. This is mastery goals centered. And basically, the way that this was created, I'll just kind of demonstrate it, and then I'll move on. So essentially what I did was I went to Analyze, Descriptive Statistics, Descriptives. I moved the original mastery variable over to this box, clicked on OK, and my descriptive statistics, you can see down here that the mean was 100 for that particular variable. So what I'm going to do is I'll go to Transform, Compute Variable, and I'd be creating a new variable. It was just basically mGoal centered, and I'll just kind of overwrite what I already had. It's not going to change anything, but just to show you how it was done, I moved mastery goal over to the numeric expression, then minus 100, which was the mean for that variable. Clicked on OK. Again, I'm going to overwrite it. And now you can see that, this is what we just created, or overwrote the original variable. So it's exactly the same as what we had before. So now when I go to analyze regression, linear, I'm going to take this gender ID variable out, and I'm going to include my effect-coded variables along with mastery goals centered. So when I click on OK, you can now see in our output, first off, let's you can see there's the R-square value and then the F value and P value. If we go back and we compare with the ANCOVA table that we had above, you can see again there's the F value and P value, and there's that eta squared value, which is 0.306. So the F value, P value, and the eta squared value are the exact same values that we had in our regression output. Next, when we scroll down and take a quick look at the grand mean right here of 97.883. So let's compare that to the intercept. And so in this case, you can see in our regression table, there's 97.883. Here are our deviation contrasts using our effect-coded variables. So there's a negative 2.884, standard error of 1.704, and then there's our p-value. So let's go back and look at the first of our deviation contrasts in this table. And again, there's a negative 2.884, there's the standard error, and there's the p-value that's reproduced in this table. So you can see these are the exact same numbers that you see in our regression coefficients table. So there you go. Okay, so finally, for a little bit more fun, what I thought I would do is build a model that incorporates the education level variable, gender ID variable, and our covariate in it. So let's run, first of all, let's run our model going back through general linear model, univariate. And in this particular case, what I'm going to do is add gender ID, the original gender ID, to the fixed factors. In this particular demonstration, I don't want an interaction between these two variables to be incorporated in the model. So what I'm going to do is I'm just going to go up to this model tab right here, click on build terms, and I'm going to remove interaction. I'm going to go down to main effects and include education level, gender ID, and mastery goals as the predictors in the model. So if I didn't do this, if I left this as full factorial, what would happen is that when I run the ANCOVA, essentially what I would include in the ANCOVA output would be both the main effects of education level and gender ID as well as an interaction term. But again, for this particular demonstration, I'm not going to be doing that. So that's why I'm going through this route. So we'll click on continue. I'll click on estimated marginal means again, and we'll move this over as well. Click on continue here. Under contrast, I'll go ahead and reset both of these so that they are deviation contrast, so you can see what these look like. And we'll click on continue and then on OK. And so now you can see in this particular case we have our corrected model. This is the overall model fit, if you will, if we're thinking in terms of regression. This would be equivalent to the R-square value from the regression, which you see reproduced down below. There's the F value and the P value that's given right here. So let's really quickly run this using regression. So we'll go back through regression, linear, and I'll just go ahead and include the gender ID effect-coded variable alongside the education level effect-coded variables, and then our mastery goals centered, and we'll click on OK right here. So here you can see there's the R-square value that we saw previously in the ANCOVA table, as well as the F value and the P value that were given above as well. So this is, again, reflecting the overall model fit. When we look at our results for the coefficients, again, there's our intercept, 98.073. So if we go back to our ANCOVA results, specifically the marginal means output, there it is right there, 98.073. And that number will be equivalent whether we take the mean of these means for the educational level variable or the gender ID variable. It's going to be yielding the same value. Then the regression coefficients that you have right here are essentially the comparisons of a specific target group and the grand mean for, so this is basically that group 2, which is the somewhat low group, versus the grand mean. This is group 3 versus the grand mean, and then group 4 versus the grand mean. There's a regression slope for mastery goals, and then there's essentially the difference between females and the grand mean for the achievement variable. And just for the sake of completeness, let's just take a quick look. There's a gender ID variable. There's our standard error and our p-value right there. Let's go back up and look at the deviation contrast and for gender identification. So you can see right here, there's the 2.498 with respect to our gender identification. There's the standard error and our p-value of 0.014. So again, those are the exact same values that we see for our gender ID variable that's represented in this row in our output. And then our slopes for the effect-coded variables related to educational level are essentially representing those deviation contrasts. And so if we go back up here and we look at the deviation contrast, there's the first contrast, level 2 versus the mean of the group means, level 3 versus the mean of group means, and then level 4 versus the mean of group means. And then you see our standard errors and p-values are all the same that we have in our regression table. So that pretty much concludes this demonstration of effect coding with multiple regression. And once again, let me just reiterate that I do have a PowerPoint that's linked underneath the video description, so be sure to check that out. And also the raw data for this particular demonstration. There's also one additional demonstration in the PowerPoint that I'm not going to go into here, but that's just showing you using effect coding when you have equal ends. There's no difference in how you model it, but in that particular case, if you have equal ends across your groups, then what that will yield is an intercept that is equal to not only the mean of group means, but also the intercept would be equal to the raw score mean across groups for the dependent variable. So at any rate, that concludes this discussion, and I appreciate you watching.